So the first speaker in this lineup is Denovan Chauveau. He did a postdoc with us here, and then he moved on to France. So thank you, Denovan, for coming back to Venice and showing us what you did during the project.
So hello everyone, my name is Denovan Chauveau, and today I'm going to talk about some of the work I did during my postdoc with Alessio and in the Warm Coast project. So this work concerned coral reef modeling from the Last Interglacial. So let's start. As this beautiful photos in background of Curaçao shows, some coasts are characterized by steppe morphology, which are due to emerge coral reef terraces, fossil coral reef that result from the interaction of land motion and past sea level fluctuation. And each step corresponds to fossil coral reef, and we call that the coral reef terraces. And these are characterized by an inner edge, which is the paleo shoreline, so the paleo limit demarking the paleo reef from the coastline. And higher the terraces, older it is. So as you all know, we can date coal from these surfaces, and with different techniques such as U-series, and then associate an age and a marine isotope stage to a coral reef terraces. As Alessio described in 2016, and as you all know and we talk since few days, from the elevation measurement of the inner edge of the terraces and the dating of organisms from the same surfaces, we can reconstruct what we call relative sea level, which is a local past sea level. So for concerning the coral reef from the Last Interglacial, there are many sites. Many sites have been studied all around the world, but there are particularities stand out in most of them. Indeed, many authors have observed abrupt changes in geological facies or the presences of several terraces associated with this period in both tectonically active and tectonically stable area. So here we have a map from Rolling et al. 2019. Here we have an example of the Grand Tinagua Island in San Salvador in the Bahamas archipelago, where some author described a younger reef unit above an older one, and the both sometimes are separated by an erosional surfaces of or a rubble layer. We have also the very well-known example of Yucatan, where Blanchon et al. Described what we call a backstepped reef. So in this case, it's It's the formation of a first reef crest around 3 meters above the present sea level, from 126 to 121 km ago. Its abrupt demise and the construction of a new reef crest several hundred meters further inland at 6 meters above the present mean sea level from 121 km ago. So from these particularities, the author deduced an abrupt sea level rise rate around 10 millimeters per year in the middle of the Last Interglacial. So it's quite huge. And so at the end, it's many sites all around the world. We also have the Western Australia case where Hertie described 2 levels of terraces, and later O'Leary deduced an abrupt rise again around 10 millimeters per year, which is higher than the current sea level rise. So all that site and this period, the Last Interglacial, is a very nice analog to the current sea level rise. But it's so where there are rapid sea level fluctuation during the Last Interglacial, it's still under debate because there are some geological features are absent on many other sites. Some authors say that in the Caribbean there are the GIA which could affect this particular coral reef. And Also, there is the influence of tectonic movements. There are some recent modeling studies showing that in tectonically active area, like in Indonesia, for example, previous reef construction will influence new one, creating multiple terraces associated with one sea level rise. So the question I asked is, what are the genesis mechanisms behind this geological feature in stable area? So in order to answer this question, I use a reef code, which is a kinematic model based on the reef morphology and defined by effective laws for each parameter, which are G, the reef growth, E, the marine erosion, S, the clastic sedimentation resulting from the erosion, U, the uplift rate, alpha, the bedrock slope, and of course the past sea level fluctuation. So for this study particularly, I didn't use an uplift rate because I wanted to be focused on stable area, but I use very wide range of values for each main parameters, so the reef growth, the erosion rate, etc., in order to test as many combination of parameters as possible. After that, I use 17 last interglacial sea level curve coming from published paper or handmade curve in order to test different sea level fluctuation pattern during the last interglacial. And so at the end, I obtained around 50,000 simulation of coral reef development for this period, and I score each of the simulation based on 3 criteria. So 1 point when a criterion is reached. The first one is obviously one emerged coral reef terraces or reef unit. The second one is the presence of multiple coral reef terraces associated with the last interglacial. And the last one is the formation of a younger reef unit above an older one, because this is what we want to reproduce with the model. So here we have all the results. In the y-axis is the percentage of model runs for each sea level curve, sea level scenarios, and we can see that around 60% of the total simulation reach a score of 3, so creating multiple terraces, and 2% of the total simulation reach a score of 3, yeah. So the formation of a younger reef unit above an older one, and but only for 3 sea level scenarios. So the one coming from the curve of Rolling et al. 2009, the one peak scenario, which is just a long and relatively stable sea level ice tone. I was a bit surprised to obtain this result. And the last one is the low first peak followed by a second higher peak. So here are some examples of simulation resulting from this study. The first one on the top left is one of the simulations coming from the curve of Rolling. And what we can see with this study is that the curve of Rolling, so here, is the only sea level scenario which is able to reproduce a proper backsteped reef during this period. And this is due to the sea level rise rate of 9 millimeters per year between the first and the second peak of this curve. So what's emerged from the study is that the only sea level scenario that could explain generation of emerged backsteped reef during the last interglacial is the first peak, followed by an abrupt rise, maybe a sea level fall between the both peaks, but followed by a second short-term peak in order to avoid a reoccupation of the first reef unit. But for the other two scenarios, it's not the sea level rise rate would be explain the formation of this younger reef unit above an older one, but the erosion of pre-existing surfaces during sea level regression. So typically for these two cases, at the end of the last interglacial, the sea level erodes the top unit. So, except the case of the backsteped fossil coral reef coming from Rolling, we can say from the study that any other multiple step stratigraphy can be explained by the interplay between reef growth, marine erosion, and bedrock slope. So to conclude, again, the last interglacial is an analog for warmer future. Fossil coral reef are very good environmental archives, provided that all the processes involved in their genesis are taken into account. There are many sites all around the world that are believed to provide evidence of abrupt sea level fluctuation during the last interglacial, but some can be explained by marine erosion, mainly in stable area, previous topography in tectonics area, GIA maybe in the Caribbean mostly, and local tectonic movement. And I wanted to finish by saying a big thanks to Alessio to allow me to do this postdoc. It was a great opportunity to meet wonderful people and made a solid scientific connection. And so thank you to all of you, and I invite you to come and see my poster and policy focus on fossil coral reef of Aruba, the small island in the Caribbean. And thank you for your attention.